Welcome everyone to our December, our final 2023 of the year Beak Share and Learn. Today we have a really cool special guest, Dr. Ali Ansari from the University of Illinois Urbana-Champaign. Dr. Ansari will be presenting a little bit of work he's doing in implementing game-based learning modules into core engineering curricula. A very cool topic, and I'm excited to learn more. So without further ado, welcome Dr. Ansari.
Hello. Hello, everyone. It's honestly super a pleasure to be here. I love talking about games in general and also teaching. So this is like totally up my jam. And if I go over time, I apologize in advance because I'm going to do my best, but also I might go rogue. But to begin with, I just sort of like wanted to talk through sort of what the agenda was for today. I'm going to talk about who I am for a sec, just to sort of build my street cred. I'm then going to go through some of the different things like what is game-based learning, which is in particular what I'm talking about, and some of the motivations behind what I'm doing, and then some of the things I can improve upon, of course, and then also what I succeeded in. So both not the cons, but like some of the limitations and then some of the advantages, I think. And then, of course, the reason that you guys are here, how I can help you guys sort of start to do it yourselves. And then, of course, some future iterations, but that's if we make it there. We don't know. So beginning with sort of who I am, if you don't know, my name is Ali Ansari. I am currently a teaching assistant professor at the University of Illinois. I really love doing this. Previously, I was a visiting assistant professor at Bucknell University, which is another university that sort of focuses a lot on sort of student-centered learning. So they gave me a lot of latitude to sort of build these sort of modules and a lot of direction in how to sort of do this. I really appreciate it, honestly. But I taught in both the electrical engineering department as well as the biomedical engineering department because I was a visiting professor and we're basically hired mercenaries. We teach whatever we can. Much of my content was sort of developed there. So you'll see me sort of list a lot of those classes when I talk about them. Of course, as everyone else is, that's not even close to my expertise. My expertise is actually in material science. I did a lot of stuff with surface functionalization, a lot of stuff with cancer, but as everybody else is, I'm very easily scientifically distracted, which meant that I don't actually teach anything in that field. I've taught probability, computational models, I've taught circuits, signals, systems, everything across the spectrum. And I've found that throughout all of those different things, there's really a core message that I think all those sort of classes had, which is that there is a sort of fear with a lot of students that have taken these classes where they have really a barrier where they don't think they either belong or they don't think they can do it. It's the math is really scary. A lot of these sort of fears, I think like a barrier of fear prevents students from sort of feeling like they are enough or they are good enough to sort of be in that class. And so a lot of the stuff that I try to do in terms of gamification and game-based learning is to sort of make that barrier of fear a little bit smaller and make them feel like because the rules of the games are really easy, they've seen it before, they are able to sort of master this material because it's only a small step up from what they already know. Maybe this might help either with retention of like information, so like making sure they remember what a fast Fourier transform is, but also maybe retention of actually students themselves, because we do have a lot of sort of a loss of students, especially of minoritized populations that maybe feel othered for a variety of different reasons, and hopefully maybe gamification or game-based learning may start to stem that in some way. So that's all great. I like to sort of make the classroom a place where we give them a lot of tools and we show them how to use those tools. And then we have them break things with those tools, because I think that is sort of the reason why we teach them these certain things, right? The reason we teach them fast Fourier transforms is so that they can use it on something. It's not just knowledge for knowledge's sake. And I feel like a lot of times they frame it to be, I just need to learn this concept so I can pass, instead of this is a hammer, maybe this might be useful if I see a nail kind of thing. But I sort of try to extend those complex tools, the use of those complex tools a little bit beyond what they're supposed to be used for. I try to put them in the most absurd kind of situations because when you can laugh at something, you're less likely to fear it. And so I've done abominations with MATLAB because I think that is funny. And so that's the main premise of a lot of what I do is I try to make it a little bit absurd. But what is gamification even? What are we even doing? What is game-based learning? You may have heard of game-based learning, you may have heard of gamification, but if you don't, it's my job to sort of tell you what it is so you're not completely lost. There's actually sort of two different things here. Gamification is not the same thing as game-based learning. It's like they're two siblings and one's the elder brother and one's the younger brother. Gamification is a lot of sort of building a entire sort of framework in which you put everything else into. Game-based learning is usually making a small module or small sort of a game and using the game to have housed the actual assessment itself. So to put this in perspective, I can build a small game, and in that game sort of allow them to learn a concept. Let's use Fourier transforms again. And then within that game, they would be assessed based on how they do in that game. And that would be game-based learning. Gamification sort of involves taking everything, the entire class, and building it into a game. So it's not that you are assessing each individual thing, you're really, the entirety of that course is the game and other things are going on in there. And then at the end, based on whatever metrics you're doing, you would then assess that overall. So the assessment isn't in the game for gamification, but the assessment is the game in sort of the game-based learning. Now, there's a lot of different things. I like puzzles because a lot of times when you sort of make people compete, it makes some people feel bad if they aren't competitive. And that's not sort of the vibe I'm looking for. So a lot of the stuff I do is puzzles. I make a lot of different ciphers and stuff, word-based puzzles, math-based puzzles. And those are sort of the game-based learning things that I do. I want to make the game the vehicle to sort of deliver the actual assessment and exercise that we do. And so that's sort of how I frame what I do. As I mentioned, you can do the entire gamut, right? Like there's so much you can throw together in a game-based learning or even gamification course. You can make leveling up, you can make collectibles, you can make badges, you can make perks. Like for instance, if they master 3 concepts, maybe they have extra 10 minutes like that they can have on a homework assignment or whatever. But there's different things you can do in game-based learning or gamification that you can't really do in game-based learning, but gamification isn't what I want to talk about predominantly. It's a lot of work and it's not something that I have the bandwidth to sort of engage with. So I really focus more on game-based learning, which I think is a little bit easier to sort of play with. But I have implemented a lot of different games. It's something that I truly have a lot of fun with. I kind of make the games contextualize concepts for students so they can better and more fully understand sort of the motivations about why we do certain things rather than just doing it for the sake of doing it. As I mentioned, I want them to be more creative on how they apply things and also increase engagement and make it a little bit more accessible for students that don't respond well to just being talked at or just doing rote sort of questions. So kind of more beyond the sort of auditory and visual learners. But how did I do it? There were 2 basic ways that I sort of talk about this. There's a lot of different ways to implement game-based learning. It's not something that I'm going to sort of reduce down to only 2 different ways, but I focused predominantly on sort of integrating it in my lectures and then integrating it in my labs. It's a little bit harder to integrate it, for me at least, into the lectures. It lends itself a lot more easier when you do it in labs because you're already demonstrating something, and just changing the way you demonstrate something is a little bit easier, at least for me. But you can also do it in lab-based lectures as well, or lecture-based stuff as well. But I'll start with going over what I did, and then I'll go over on how you can do it too, because I feel like that's a better way to frame it. In my lectures, I played a lot with trying to figure out how the best way to sort of have the students sort of respond to games. But what I found is that there's a little bit of a cost associated with sort of having these sorts of games. Just like all active learning techniques, if you try to implement some sort of game-based learning technique, it comes at the cost of time, which is something that's usually limited in core courses. You have a finite amount of time, a certain number of sort of modules you have to cover, and you have to make sure that you sort of get through all of them sufficiently well. And while there are some flexible places, like instead of like talking about Fourier transform for 3 days, maybe you can talk about it for 2 days and then have an example or a game to sort of go over that last day. If you keep doing it for every single concept, you sort of start to, there's a cost associated with how much you can cover and what depth you can cover is my main point. That being said, the way I did it was I structured the class from the beginning with the idea that I wanted to have these games in there. And so for one of my circuits classes, I covered material on the first 2 days. So both Wednesday and Monday, I would go over materials. And on Fridays, I would have something I called Puzzle Fridays, where I would have and this class really loved competition. So I focused on mostly like competition against each other. But it'd be a class competition where I'd give them sort of a quiz. And the quiz would have sort of questions about like, okay, what did you learn over this week? But it would also have stuff that would be completely outside the realm of what they've ever seen before. It was a way of sort of doing application-based like sort of assessments where I would have them go over different kinds of circuit elements. So like, a low pass filter, a high pass filter. This is an op amp. This is a speaker, so on and so forth. But then I would give them circuits from devices they've used in their lives. So I would give them like a schematic for a computer. And I'd ask them, what do you think this schematic is? And based on sort of their knowledge about this is an op amp, this is this, whatever, this is a battery, they'd start to make educated guesses about what they thought this was. And then from that, tell me, okay, well, I think this is some sort of device that does X, Y, Z. And now, not all of them were laptops. I only did laptop at the very end because they kept knocking everything else out of the park. But the beginning circuits was like, I had like a stupid sensor that was, like in the spy movies, how they have like lasers. And then when you break the laser, it sets off like a little speaker. I had a schematic for that. And they were like, it's a thing where if the light's interrupted, the sound goes off. And I was like, correct. But I would do that for like a lot of stupid things. I had a CPAP machine circuit in there. I had a refrigerator. I had freezers. I had a lot of different things in there. But the idea was I wanted to build their confidence in being able to sort of diagnose and see this is what the circuit's supposed to look like outside of just this is like a voltage source. This is what a resistor looks like. And sort of that was the idea. And then if I could reward them for getting the highest score in the class, then, they got a donut or they got a candy or whatever they wanted. So that was that. I've talked too long about this. I'm so sorry. Another sort of thing that I did was at the end of each sort of lecture for a lot of these classes, I had a think, pair, share thing where I would basically give them open-ended problems or questions that didn't actually have an answer. But the idea was to sort of get them to start talking to each other and see that other people had different sorts of perspectives on different kinds of things. Obviously, this doesn't scale the best with classes that are 60 plus, which is something that a lot of us deal with. I try to do a cipher or hidden message in a lot of those different kinds of questions at the end of class, just because I was like, okay, well, I can just run around and see if everybody got the right answer. And that kind of worked, but I wanted to do more in the lecture and I didn't have the bandwidth or the time to do so. So that's something that I am constantly working on myself. With controls, I made a complex game activity where I wrote a game and everybody was supposed to be a part of an actual like sort of a game activity, or they were each part of a control system. So I had somebody who was the plant, I had somebody who was the sort of controller, I had somebody who was the actual like feedback loop, and I had different dice that represented the nudge and stuff. And it was great, except for that it was so complex that it took me 15 minutes to teach them and then 15 minutes for them to do it. And then half the class didn't understand it. And the students that already got the concepts like thought it was amazing. And the students that didn't understand it didn't get any better. Next time we opt for simpler rather than more complicated because I lost the thread of what I was trying to do. But yeah, so we tried a lot of things. I also tried to do something called I tried to do something called dueling journal clubs, where basically I had 2 papers I wanted the students to read. One paper, the half the class had to present, the other had to present the other one. And I basically stood in the center of this huge round table, and they basically talked about the paper. And I chose the papers to be different sort of perspectives on the same sort of problem. So let's say we talked about glioblastoma. I'd have one paper that was written by material science talking about glioblastoma or a solution to it or a review paper or what have you. And the other one being from either a biologist or an engineer of some sort talking about the problem from their lens. And the idea was that neither was more apt or more valid, but both had this sort of perspective of these are the things that are important and these are the things that we can do to solve it. And it was very interesting from the students' perspective, I think, to sort of hear that other people were trying to solve problems completely in a different world. So I did that as well. Now, like I mentioned, that was just for lecture stuff, because labs are so much more free in terms of how you want to present these things. In my computational class, I talked a lot about how I could make MATLAB-based puzzle systems because a lot of my classes use a MATLAB. So I sort of tried to figure out how to do that. And I wanted to make MATLAB less intimidating because a lot of people feel like the learning curve for MATLAB is so hard. I don't understand it. I don't know coding. I don't understand this. I'm never going to be a coder. I just need to get through this class. And so I wanted to make it so that the rote parts of coding weren't as terrible, because a lot of times the way we teach sort of coding is, here's a for loop. This is how you do it. This is the way that you have to keep doing it. And it's kind of boring that way. I wanted to see how students could get direct application for the codes they're writing and how it was built. So I made a murder mystery. Basically what I did was I wrote a lab and I forced them to do different things that they'd already done in the semester. So writing for loops, figuring out how to sort of find the answer to a bunch of logic puzzles. And then I had them write sort of a conditional statement, for instance. And through that, they would solve this mystery that I had put together. I also made it so that I had like a murder crime scene and they had to denoise it because I had put Gaussian white noise in there and they had to do all sorts of filter stuff. It was great. Took me a long time. But it basically allowed them to sort of as a like summative sort of assignment, build on all the different formative things that they'd done in the previous labs. And so that was helpful for them, I think. I also did one that I really enjoyed called the Uno Reverse Lab, where basically students were sort of given a opportunity to write their own puzzle, and they were forced to sort of give it to another person who had to solve it. And so they really liked that because they didn't think that they could write a puzzle because they'd seen me write it for like 14 or something weeks. And so the last lab was just this. But they actually did a really good job. One person made Battleship in MATLAB, which I've never taught anybody how to do, and I've never seen somebody how to do. So it's crazy. I did some exit surveys at the end of the class. I basically asked them at the beginning of class how confident they were, what did they think that they could do in MATLAB, and they basically gave an initial score of like, I'm 1.4 out of 5 confident in MATLAB. At the end of the course, they had more than doubled it, about 1.4 fold more to about 3.5. So they were about almost 4 confident out of 5 in MATLAB. So that made me feel really good about it. But probability, I also did some stuff. I did a lot of stuff where they did cross-correlation stuff with different images, so how to denoise stuff like that. I also did some stuff where they would use M&Ms to sort of represent chi-squared value and stuff like that, because I want them to see how actual statistics matter. And so that was some of the games that I played. Signals and systems, I did everything I could. I wanted people to be able to see how signals and systems actually affected their lives and how we could play with it in MATLAB. So I did a lot of stuff that was sort of orthogonal to what they've done before in terms of making it outside, like auditory, making it visual, having them sketch it, having them break it in some cases. But that was sort of the idea of what I wanted them to do in that class. And so you'll see a list of these things in another sort of slide. One thing I really enjoyed was I had them record parts of their favorite songs and have them analyze it in MATLAB and draw pictures based on Laplace transform. So like if they solved it, they got an answer and they had to draw it. And so they drew a cat at the end of it, but stuff like that. Of course, I should mention the limitations before I mention the actual advantages, because I feel like I don't want to give a overly beautified picture of game-based learning, because I think it's great and I'm obviously biased, so I need to be forefront with one of the problems with it. It's lovely. I'm not gonna lie to you. I find it great. They get to wonder at the infinite mysteries in our field. They get to play with science. They get to do all sorts of different things in a more accessible way. There are definite problems though. First and foremost, building these games is not easy. It's not like, oh, I'm just gonna go and just get a game. No, this is a little bit of brain power. It's a lot of time. You have to figure out, how you want to frame the game and what it is that you actually want to assess. And there's a lot of different parts that you need to think about. And I'm not gonna lie to you and say it's super easy. You can do it tomorrow. You might take a little bit longer. I'm not gonna lie. Once you figure out exactly how you make games, like what your personal rhythm or groove is, it gets a lot easier. But it's not to say that like, do it tomorrow, you'll be fine. I'm so sorry. My emails will just keep ringing forever. But games also have a habit, at least for me, of running away from me, where I get super into the game and I get super like, okay, this is how it's going to work. These are all the things. And if you get too excited about the vehicle and you forget to put the engine in, it's a bad car. I'm not going to lie to you. I'm not going to sugarcoat it. You got to figure out how much spotlight that game takes versus the material that you're trying to cover. Sometimes simpler is better. Like that one game I made about controllers, I had so much fun trying to figure out how one student would do XYZ that it didn't make sense when they tried to play it because they were like, why do I have to do this? Large classes definitely make games harder. Designing a game for 5 to 15 people is a lot different than designing it for 60 plus. Sometimes it's not even feasible to play games in certain classes if you have like 300 people, because it'll take so long for them to actually get up and do something that you would not be able to do all the things you'd like to do. So make sure that you implement a game for the population that you're sort of playing with. And speaking of which, you also want to make sure that you take into account the diversity of the group that you're playing with. That is to say, I have made mistakes in my life in building games. There is no one size fit all for games. And I didn't know this until I was teaching a class that was like the bioengineering class I taught. It was a MATLAB course. And then the next class I taught was in the electrical engineering department, and it was a probability course. And so I thought, okay, well, I have a lot of these crossword games. I'll just retrofit them so that they fit the class and the material and whatnot. And so I built them. And in the bio class, everybody loved them. They were really great. They filled it all out. But in the ECE course, a lot of people didn't fill it out. And one student actually came up to me and asked me if it was mandatory that they do it because they found it a hassle. And initially I was like, wait, why? Like, why don't you like it? And I realized that the students that didn't like it were the students that were non-native speakers. For them, word games weren't something that they necessarily enjoyed. For them, it was tedious, confusing, and made them feel kind of othered in ways that I didn't intend. And so I had to completely change all of the games that I had built for the rest of the semester, because I was like, I can't do word games if they don't like word games. This is the wrong population to sort of give these games to. And I realized that that's the same sort of thing if they had dyslexia or if they were colorblind. I got to be more careful with sort of how I structure games in terms of making sure that I don't accidentally do the opposite of what I'm trying to do by being more inclusive. So for this exact scenario, I did a lot of more of the coding games with MATLAB, but I did a lot more of the math-based games, or sort of using different kinds of ciphers and stuff, using math or binary or hexadecimal, instead of using any sort of word games, because I was like, oh no, I've made a grave error. But that's another thing. You also need to have a certain amount of buy-in from students. If students don't find it interesting, they don't find it sort of worth their time, they're not going to do it. If you write an entire like novel, like Twilight Imperium has for their rules, they're not going to necessarily be able to learn it in 15 minutes. I'm not going to be able to do it in 15 minutes. So just have reasonable expectations of how much they can buy in and do. Lastly, you are only human. There are only so many novel games you can develop in a course at one time. And sometimes you got to be able to understand that like shooting that gap between, not universally hated and like sort of not making it boring is a better sort of goal than making sure it's universally loved every single time. Sometimes you get that sort of golden where everybody loves it, but it's okay to sort of get like everybody's unhated and it's not boring, so it's a success kind of thing. I am like way past my time and I am so sorry. So I'm going to keep going. This isn't all bad though. There's a lot of things that games allow you to do, which is why I like doing it and why I continue to do it. A lot of students have responded that they really appreciated the game and how it made them able to code. I've gotten emails from students saying like, I thought I was going to never code in my life, and now I'm doing it for my sort of like internship over the summer. I hate that you made me able to do this. And I was like, that's fine, I'll take that. But a lot of games are sort of built to sort of build that confidence and allow them to play. And both of those are really powerful motivators. And I think that that's one of the reasons why games are wonderful. Also, I can make abominations in MATLAB that no one should ever see. This right here on the left is a word search that I forced MATLAB to make. I used symbolic variables. MATLAB was very pissed at me, but I made it put every single one of those into individual vectors and then tied those together to make a matrix. This is hell. No, God never intended this to happen. This was terrible. But it allows students sort of understand that these really complex tools that they usually just like kind of fear and revere are kind of absurd. Like they're absolutely not supposed to do these things, but you can make them do these things because, as everything else, it's just a tool. So that's a lot of fun. You can mock them, you can humble them, and it's great. You can also allow them to sort of understand a little better how much they understand. Because if you give them a game where they understand the rules already, so like a crossword puzzle or a word search, and then they just build off it with the sort of the new stuff that you've already given them, sort of the core curricula, then they can sort of tie that together and advance a little bit further and build that confidence up. It may help them feel more like they belong in the field or belong in the department or belong in the class. And that's sort of why I like these sorts of things. That's something I really want to be more inclusive, all in all. If you make it interesting enough or you make it funny enough, they'll remember it. They may not remember the content altogether, but having them sort of remember some of the game allows them to tie it back to something. It's an anchor point, right? So that might help them with retention anyway. So that's all good. Now the part that you guys came here for, how to build your own games. So first and foremost, I'm going to go through a couple examples because I think that that's probably the best way to start. The first thing that I do when I sort of write these sorts of games is decide on what I want to be talking about. What is it that I think is worth focusing on in this exact game? So for instance, let's use Fourier transforms because I've mentioned it like 30 billion times. So let's say Fourier series is what we're talking about. So now that I know what I'm talking about in terms of topics, now comes the topic or the part where I'm like, okay, well, what is it that I want them to learn about this concept? What are the learning objectives for this? What is the skill that I want them to master out of this? And sometimes it's as simple as I just want them to know what a FFT is or fast Fourier transform is. I want them to sort of recognize that music is some sort of frequency. So, let's have them do that, exactly that. So have them perform an FFT, have them see how that relates to music. Students will be able to analyze frequency and transform that into music. Very simple, one line. That is sort of what I'm trying to do. And then comes the part that's the hard part, whereas how do I make that a game? What is the medium that I want them to play in? And there's no wrong answer here, right? Like if I wanted to make this a word puzzle, go for it. If I want to make this a math puzzle of some sort, absolutely run with it. For me, I think the easiest way to do this, from my experience, is using MATLAB, because MATLAB already has a way to convert FFTs into sound. It already has resources to do that. Why work with my left hand when I'm right hand dominant? Let's do something that leans into what I'm trying to do. So let's use MATLAB. Because I want to have music, let's use something else that's kind of funny. Let's use a virtual piano keyboard. I can go online, I can find something, they can tap on it like a cat on a keyboard, it'll be great. Exactly what I want. So those two are the tools that I'm using. That's the medium. So now, how am I going to make this their own? I want them to have some sort of alignment with this, and in that to say that I want them to take something that is important to them and sort of weave it into this course so that they have some sort of anchor point, like I mentioned earlier, something that they care about that they've now seen transformed into the lesson that they're doing. So how can I make them sort of claim ownership on this? And what I tried to do here was, okay, well, everybody usually has a song that they really enjoy. So let's have them pick their favorite song and record it on their phone and then send it to themselves as a sort of file and then have them analyze it in MATLAB. That shouldn't be too difficult. That should be fairly easy. So that's what we'll do to sort of have them buy into it. Because as I mentioned, if they don't buy in, it's not going to work. Lastly, and probably most importantly, is how do we assess this? I can't just give them a thing and have go sandbox, go have fun. I'll be drinking juice in the back and we'll be done in an hour. No, I need to have something that they have to achieve, something that I can be okay, this is worth the grade that they're doing. That's why they signed up for this course. But for this exact thing, well, I already mentioned that I want them to perform an FFT. So let's make sure that they are able to do that successfully. So I'll need to know what the frequencies are of their song. And then I want them to be able to transform it. So let's have them perform part of it. So let's have them write down their notes of their favorite song. Let's have them tell me what the frequencies are associated with that notes. And then let's have them perform a small clip for it at the end. That achieves all the things I want to assess. It achieves the learning goals. We're good. We're Gucci. That's all we have to think about. If you've noticed, this is the same thing you're already doing when you're writing your course prep. That is everything. That's the same steps. I just take it one step too far. I make it a little bit more absurd than it has to be. And that's the whole game. Here's an example of this exact lab that I built, right? So at the beginning, like I said, writing music with the harmonics. That's the name of the game. That's the name of the lab. I then write some code, MATLAB code, just throw it all together, take it from places, source it, make sure that it works. And then from there, I would say, okay, well, now that they have the FFT, I have to tie this to notes somehow. So that I give them a table that basically says these are the different frequencies associated with each note on a piano. So then they have a virtual piano that they can actually click around and play whatever they want. And then lastly, task 3 would be basically, hey, this is you. I want you to type in your favorite song and then find in the notes in it and then run with it. And so you tie all those elements together and then bam, you've got this little tiny module, this little game-based learning thing. It's not super crazy. And I know I'm making it sound a lot easier than it may be, but I promise it's not outrageous. I am outrageous. This is not outrageous. This is doable. And so I've given you one example and you're like, oh, you're a fraud. You've only done one game. You're right. This is only one game. I have tons. So I have a little QR code. If you want to scan it, you can get access to a folder with like practically all of the things I thought would be relevant here. But if you don't have a QR code, I've gone through and I've put individually all of the different games that I've played here in hyperlinks. Now, to go over them, I had fun with a midterm and a final I did for this class where I basically sang part of a song for one of them, and that was the sort of signal that they were trying to do, and the other thing was the noise. And then I flipped in the final where my voice was the noise, and I had to find whatever my voice was covering up. I did the same thing with word scrambles for MATLAB. I did the same thing with crosswords and ciphers for MATLAB. I did that abomination word search that I showed you. There's the code for that somewhere. I'm going to go find that and show you guys. It's terrible. I have it's like 128 lines of MATLAB code. It's terrible. I have a murder mystery in MATLAB that I wrote. I also have a bunch of Sudoku stuffs, that Friday picture puzzle lecture stuff I did, crossword, sandbox stuff using linear transformations, sketching and secret meshes stuff. The convolution stuff, I wanted to have a visual component to it because I thought it would be really important for them to see how convolution worked. Whodunit, which is like sort of a Fourier transform math like mystery kind of thing, but not a whole murder mystery thing, and there wasn't murder involved. I also made that lab that we made together. That's number 15 on this list. And then 16 is a D&D, a Dungeons and Dragons inspired sort of map thing that I made for students to sort of play with trustability. So I got a bunch of stuff, and I don't like really know how intellectual property stuff works, but you are more than welcome to whatever you need to. Just send me an email and be like, hey, is it cool if I use this? And I'll say, yeah, sure, why not? You can put my name at the bottom or something. I don't know how this works. And that'll be all.
You put your email in the chat.
Yes, I'll put my email in the chat. It is actually like just the first letter of my name and then my last name and then a 2 at the end at illinois.edu. So like if you need to send me an email, that's how you probably can reach me. But that's a lot. It's kind of overwhelming. So I tried to make it a little simpler by saying, okay, well, decide on what type of game you want. So word-based puzzle, this is not an exhaustive list, by the way. There's like way more than this. These are the ones that I have done before. But like, if you want to do a word puzzle, you can do word searches, crosswords, there's scrambles, ciphers, hidden messages. All of those are word puzzles. I love those. Those are my favorite. Not everybody loves those. Those aren't everybody's favorite. That's fine. Math ones, sketching and drawing are great. I've also done Sudoku puzzles. Those are hard for me. Binary hexadecimal conversion to ASCII, where basically you have them solve for a certain answer. It's like a cipher, but it's kind of different because now you're forcing them to sort of work with binary and hexadecimal. And if that's something that you want to teach them how to do, that's another skill you could get them to learn. I did stuff with all the props for probability, so dice, coins, M&Ms, stuff like that. That's useful for a lot of probability stuff, and I had fun with that. MATLAB and coding-based ones are a little bit more difficult, but once you find code, it's not really difficult to do certain things. I did stuff with visualization for a variety of things like convolution or autocorrelation, cross-correlation stuff. So I had them do pictures or make pictures or identify pictures in a map using code. There's stuff where I sort of make them open-ended, where I give them any input they would like to put into a program and it would just run that. That's something that I built as well. And then multi-part puzzles, which are like basically like you have them sort of review a lot of different formative assignments into one summative one, kind of like a midterm, but crazy. But those are just some examples. And there's more different genres you could do other than these. It's just that my limited experience is just these, but you can build whatever you want. The whole point is that it's a customizable tool. And there's aims. I'm trying to build a bank of these things. If I can build like, not infinite, obviously, but like maybe more than 16, maybe I build 30 of these games, then people can use them. Because the whole idea is that I want other people to use them, right? At the end of the day, I want students to feel more comfortable. So the more people who are able to make students feel more comfortable, that's all that matters, right? So if you need them, like just let me know and you can use them. You can probably help them make them better. I'm not like a wizard at this, right? Like there's a lot of things that I could make look better. In fact, actually, a lot of what I teach my students how to do in coding is that it doesn't have to look pretty, it just has to work. So maybe I could have help making it look prettier. Who knows? But in the spare time, I've promised I'm writing a paper. I submitted an abstract to ASEE, and I probably am going to have to work on that because I haven't yet. I'm bad. I promise I'll work on it. I promise I'll get it together. It'll probably take me a little bit longer than I said it would. But that's all that. If you have any ideas, you have any questions, please let me know, because this is something I really do want to get better at. And also I hope that other people would like as well. So just let me know. Quick recap, because I feel like it's important, because I'm really scattered and I took 35 minutes out of 15. So I've done really bad here. I like making game-based models. They're a lot of fun for me. I hope they help people with retention, attrition, and belonging in STEM courses, because I think that's important that we address in a lot of different ways. They're a lot of fun. They have a variety of weaknesses, for example, scalability, but I think that they have a lot of strengths, and they're something that we can use in our toolbox if we need to. And I'd like to also reiterate that there are no perfect games, and that's okay, because you can always improve upon some of the less perfect games. And hopefully you'll hit enough of a group that it'll help them, you know? Any feedback I would love to hear, any questions I would love to answer. I can also provide more stuff, such as the MATLAB code, but I've put it somewhere and I need to find it. So that's future me problem. Because I like made them in a mad dash to sort of get across that finish line, and then I've like put it somewhere. So now I've got to find it. But yeah, so that's all I have. Thank you very much for your time and attention. That's not 100% true. I do have extra slides, but only if you ask me questions about it, then I can show you those slides.